2, 1.
Lights, camera, action.
Okay, good. All right, there we go. So yesterday, well, we talked briefly yesterday about solving systems of equations, right? And we talked about using what method? Graphing, right? And it was awesome, right? And what did we learn from it?
It's not accurate.
It's not very accurate. It's not always easy to solve them, right? Sometimes you can solve them real easily, and sometimes you can't, right? So that's a bummer, because if you're trying to get to the moon and you have to solve the systems to make sure that the two, trajectory points end up at the moon and not somewhere else, right?
Way
over, right? You gotta be able to solve it. You can't just say, oh, well, I can't do it because by graphing it, it's not very accurate, right? So sometimes instead of graphing, instead of doing it pictorially with a picture, we'll do it algebraically, and it always works, right? Now, I just want to say one other thing, because I sort of mentioned this the other day, but I didn't really write them down. But you'll see them called different things. They call them systems of equations, systems meaning more than one, right? Like a stereo system, more than one thing, right? Linear systems. Linear, always, when you see that in math, it always means a straight line. It never means a curved line. Linear means straight line, okay? Even though a curved line is also linear by an English standard, but not by mathematical standards. Linear means straight line. And then the other way is the other way to describe them is actually my favorite, but I don't use it because very few people use it. But it's called simultaneous equations. Simultaneous equations. Think about it. Two equations on the same graph simultaneously, and they cross somewhere, right? To me, that makes sense, right? As opposed to systems of equations, and you have to remember, okay, what is a system? System is like stereo system. Okay, yeah, right, two, right? But simultaneously on the same graph, that's awesome. But it's just not used very often. Yeah. So I tend to use linear systems or systems of equations, just because you'll see them more often. But so today we're going to talk about how to do it algebraically, meaning instead of drawing pictures, we're going to be able to add, subtract, multiply, divide, and solve our equations and get an answer, right? Okay, and we're going to use this method called substitution. Remember, there were 3 ways I told you yesterday that you can solve systems of equations that we're going to work on. One is graphing. The second one is substitution. And the third one is elimination. Yeah, good job. Right? Like Terminator. Sort of like the Terminator. Is that what you said?
If Luca was here, I swear.
Okay.
Right.
So, all right, here we go. Let's say I have 2x plus y equals 10. Okay. How many variables do I have in that? 2. In order to solve this, how many equations would I have to have? 2. Why?
They could go either way.
So if I wrote in a second, do you believe that I could write a second equation that would allow us to solve this?
Yes.
Does everybody really, truly believe that?
Yes.
All right, so I'm going to write a second equation that will allow us to solve this.
Oh.
What?
It does, actually. It completely solves it.
Oh my god, what?
Because y equals 4.
If y does equal 4, could I substitute
Yeah.
4 into this equation? Right? Right? So here we go. I'm going to take this 4. Guys, listen. So this is what I'm going to suggest you do. And a lot of people don't do this. I really suggest you do this. You circle. Basically, in order to solve these, you have to find an equation that says y equals or x equals. So number 1, you must find y equals or x equals, right? Number 2, circle what it equals. what it equals. It really helps you, believe it or not. People think this is stupid. Stupid, right? It's not stupid. It's really actually helpful because it will remind you what to do when you're actually solving the problem. When I actually give you a problem on the test or something, you get, it's easy to forget. Oh, I got to look for a y equals or x equals. It doesn't say y equals here or x equals, but it does here. What does y equal? 4. So I'm going to circle 4. But what does 4 equal again?
4.
Y.
It equals y. 4 equals
Why
y.
does that equal 4?
But
Right.
if y equals 4, then
Okay.
4 equals 4.
So 4 equals y, right? 4 equals y. That's interesting. Think about it. Would you agree with me if a point, a solution to a system, guys, are you listening?
Yeah.
If a solution to a system is one point where they both cross, is that point on both lines?
Yeah.
Is that point the same y on both lines?
Yes.
Is that point the same x on both lines?
Yes.
So we're saying that the y's and the x's, we're looking for a place where the y's and the x's are exactly the same. Am I right? So why not make them the same? If y is equal to 4, why not make that y equal to 4? So I'm going to actually circle this y, and I'm going to put a little arrow here, and it reminds me I'm going to substitute that 4 into the y. So now I'm going to write it with the substitution. 2x plus, instead of y is equal to 4, so I'm going to write 4 equals 10. How many variables do I have now?
1.
How many equations do I have now here?
1.
Can I solve it?
Yes.
Absolutely.
Wait, Gary, couldn't y also be 2?
Where are you seeing that?
Like,
It
instead of
it says
making
it
it
there.
4, couldn't you make it 2? Because 2x could be 4.
But that's problem.
If that were the problem, but that's not
Yeah.
the problem. The problem I gave you is y equals 4.
But it's
That's
just
just,
an equation.
that's just how the problem is. at the
This is your
lowest.
problem
You're
that I
not
set
trying to
up.
look for other variables.
I could say y equals 20. I could say y is 1,000. I could say y is 1,000,000. But this is the problem we're solving, not that one, right? So we just got to use what we're given. This is given. And so we have to solve what's given, right? Does that make sense?
Yes.
Got it. Okay. So now I would just quickly solve this. Subtract 4 from both sides. And I have 2x is equal to 6, right?
And then divide
And
by
then
2.
divide by 2. Divide by 2. X is equal to
3.
3. X is equal to 3.
That's it.
Am I done? The solution is what?
X. 3.
Is this? All right. Where is that on the graph?
Somewhere there. Where line intersects.
Under the point.
It's at that place.
It's
3. No.
It's at that place.
Oh, we actually have to do it.
If the solution was right there, all I have to say is x is 3.
No, why is
Oh, I have to know what y is.
4.
I have
Y
to
is
know.
4.
Guys, listen. I have to know what y is. So how would I figure it out?
Right
Y.
there, y equals
Y
4.
is 4. It gave that to me. That's great. So that's my answer.
Couldn't we also
Now,
do 3, 4?
I could also write this as the answer is 3, 4. Because x comes first and then y, right?
Yeah.
I could write it either way. So that would be my answer. It's pretty easy, right?
Yeah. Yay.
So we quickly did it. We're done.
I have a question.
Yes.
Well, it's not like this, but it's a graphic.
Yep.
If like x equals like 20 and y equals 10, right?
Yep.
Wait.
Wait, he didn't take a picture.
Can you? No,
He never took a picture.
Bravo!
I watched the video. Why is it that when I'm not here, you remember when I am? Yeah.
That's true. He did
All right.
remember.
Oh, fabulous.
You forgot
All right.
the coordinates.
Oh, and just said, can you make it so?
Take a picture.
Forgot
Quick.
the coordinates.
Take a picture.
Coordinates.
Guys. Quick, because I have to do one more thing before I let you guys go.
Take your time, mister.
That was a close. Unless you get the iPhone 6.
He did it. He did it.
Got it? Okay. All right.
You did? Well, now,
This is every day.
Vivian.
My name is Didion.
Okay. Okay, guys, can you have it quiet? Can I have it quiet? All right, I really have 1 minute. Okay, that's literally all I have. So I'm going to
Do it
write this.
quickly.
we're doing a second one really fast. Write it down.
Okay.
Okay, y is equal to 3x plus 2 and x plus 2y equals 11.
Oh. Okay.
So now this is harder. There's still two variables, two equations. It's not quite as easy, but I have to remember I have to find something that says y equals or x equals. Which one?
Y equals 3x plus 2.
What?
Can I repeat the y in this form? Y equals 3x.
Yeah.
Plus 2.
Yeah,
Can you
that's
just do that?
exactly. The y equals is mean the y-intercept, exactly. Y,
Can you just do
the,
that
the
instead of
slope-intercept form.
Instead of the substitution.
Oh, no. Because right now we're doing substitution. That's what I'm teaching you, this method. Right? So we found it. So this one says y equals, right?
Yeah.
And then it says I have to circle what it equals. I'm going to circle this.
Oh,
Now, what does this equal again?
3x plus 2.
It equals y. Therefore, let's replace this y with that. So by circling those two things and putting a little arrow, it's almost impossible to do this
So
wrong.
x equals plus
X plus
2
two
times
parentheses,
3x plus
right? The
2.
parentheses are important now.
Oh, I get it.
3x plus 2, you see, I'll understand why you have to have parentheses,
Yeah.
equals 11. And then I'm going to use the distributive property, right? So x plus
X
6x plus 4 equals 11
7x
7x
plus 4 equals 11.
plus 4 equals 11
Minus 4.
minus 4. 7x
7x equals 7.
7.
Divided by 7. Divided by 7. X equals 1.
X equals 1. Look at that.
Y.
Right? You guys see what I did?
About y.
So now, for y, I can take either equation and substitute 1 in for x. I can substitute, remember, because the y will be the same for both equations, right?
So then it'd
So,
be 1
I would
plus-
choose this one, though, because it already says y equals, and that's what I want it to say, y
So then
equals.
it would be
3
1
times
plus
1 is
3.
plus 2 is
5.
5. So y is 5.
Oh.
So you could say it that way, or you could say 1 comma 5 is the answer. Right?
Yay, we did it!
That makes sense? Don't quickly take a picture, Michael.
We gotta go.
I like it. I did it.
Did you did it already?
I did it.
Wait, you're supposed to tell me. I was going to jump
Oh.
to try to cover it up. Oh, shoot. I've got this on.